I am sure that he doesn't need presentation because he has been with us all the time. Dr. Pedro González Muniesa is a lecturer at the University of Navarra in the area of nutrition. He has spent almost 4 years at the University of Liverpool, and he's going to present what I can say as an original view about how to treat obesity. The role of oxygen, hypoxia, hyperoxia in the treatment of obesity. I think this is a very original topic that maybe in the future you can say. The first time I hear about that was in San Sebastian. Okay? Thank you very much, and the floor is yours.
Okay, so first of all, I'm going to start with a question. Everyone has handed the questionnaire? Yes? So I have no pressure at all. Nobody's going to evaluate me then. So first of all, I'm going to talk about oxygen therapy and obesity. And as you can see there is not only my name, but also Pablo Quintero, which is back there hiding, and Alfredo Martinez, also Aritz Urdan-Pilleta, who's not here. And I would like to say also that we have had the collaboration of different stages of several people, Raúl Urdaniz, which is back there as well, Fermín Milagro, and Javier Campion. So I'm pretty sure you all have a summary of my talk. It's divided into 3 paragraphs, which is the order that I'm going to follow, and it's pretty much what I'm going to say, but much more extended. So I would like to start very general, and then I would go very slowly into the specifics of the question. So general introduction, oxygen and its importance, relation between oxygen and obesity, the hypothesis that started all these studies, and the oxygen therapy studies that we have conducted in our unit. So the introduction. I would like my talk to be as simple as possible and as interactive as possible. I know the other speakers have tried it. I hope I would success a bit more than them. So the introduction. You saw a bit, but not all. So anyone can tell me an animal or plant who can live without oxygen? No? Nothing? Well, the answer is over here. In 2010, a group from Italy and from Denmark discovered for the first time a multicellular animal who can live without oxygen, which is in the depth of the Mediterranean Sea. And also at that place, they discovered some bacteria, some unicellular animals, or, well, not properly animals, some unicellular living creatures. Okay? So, that, I suppose, it means oxygen is important. Something else about the importance of oxygen. We saw part of this equation in, I think, in Guy Plasky talk, one of the very first. Nutrients plus oxygen, we get CO2 plus water plus energy. Okay, so it is very important, oxygen, for us to get the energy. So a very quick exercise. I want from all of you to stand up and sit down twice. Come on. Okay, very well. I think everyone did it. So after you did that very easy exercise, I would say probably most of you are breathing a bit heavier than before. you didn't realize before you were breathing. Now you realize you're breathing and you're breathing a bit stronger. So that's because you have asked your body for energy to do a physical activity. And to get that energy, you have asked your body to get more oxygen. The nutrients were stored in your body. You will get more nutrients at lunch, okay? It was an easy exercise, so you won't faint or something like that because of that. The other thing I want to say is that we are talking here about personalized nutrition. So every human being uses the oxygen in a different way, more or less efficiently. That's part of also of the equation of the energy, okay? So you have seen, and you can check with your colleagues next to you, that depending on how efficient is your use of oxygen, you are breathing heavier now or less heavy, okay? So there's a difference between us in the use of oxygen. Well, you can see that fire. So that reaction is a normal burning reaction. If we have a chimney, we use wood, that the reaction would be exactly the same, okay? And you can see down there, very small, 90% of our energy is obtained via oxygen. And also, you have there our circulatory system, which is very important to move all the oxygen around our body to get to the proper tissue where we want that oxygen. That is going to be very important afterwards. So keep two thoughts now. One is we need the circulatory system to get the oxygen to all of our different tissues, and we have different use of oxygen depending on the person, okay? Also, well, obviously I'm not going to explain all that figure because it's quite complicated, but you can see here the size of the fruit fly is getting bigger as we get more oxygen. Or looking in the other way, if we have less oxygen, we get a smaller animal because we can get less energy. So the body adapts to that situation, and after some generations, we get a smaller animal, so it needs less energy. So before I get to the next one, anyone knows where we get our oxygen? It's not a tricky question, it's just an easy one. But not everyone knows, so I just want to make sure. Please? On the air, in the atmospheric air. Okay. Now I'm getting to a more difficult one. What percentage of oxygen we have in atmospheric air? I'm hearing something, but I'm not paying a lot of attention because it's not the right number. Someone else? 21%. Okay? That's the right number. So at sea level, so here, for example, we have 20% of oxygen. You have, in brackets, another number which, for that one, it says 100%. Okay, I'm going to explain that just now. If you go on a plane, which you probably didn't know about this before, you are much higher than that, than 2,000, 3,000 meters. You are very high, and you have pressurized cabins. Okay? So because of that, the quantity of oxygen is the same, but the quantity of oxygen that our blood could take is smaller. That's why it says that 75%. So because of that pressure, we could get less oxygen, which is around 15%. Okay? So we'll see later, but we are in a hypoxic situation on a plane. At the left, this is the highest city in the world, in Peru, 5,400 meters. They have 50% of the oxygen that we have here. So they are living with 10% of the oxygen. And if you are like Juanito Oyarzabal, you can get to the Everest and get as little as 7% of oxygen, okay? So oxygenal illnesses. The photos over there are very well known for most of the Spanish people, I suppose. It's, well, 1, 2, 3, in English, 1, 2, 3. And I would say, obesity, for example, obesity. 1, 2, 3, answer again. Which other illnesses would you say are related with oxygen? So you can see a wide range of diseases that are related with oxygen. The most important ones, or the most important ones at least for me, would be obesity, all respiratory problems, heart failure, cardiopathies, sleep apnea, cancer is very important with hypoxia, and also aging. So you think this would be all of the diseases related with oxygen? Okay? So we've seen the introduction. Now I'm going to get into the hypothesis. Okay, a few years ago, we knew about hypoxia. We knew about the hypoxia in relation with some diseases, but we didn't know about hypoxia and obesity. So back in 2004, somebody from the University of Liverpool made a hypothesis, which is what I'm going to explain now. With these talks, you have seen many things about obesity, but nobody has paid attention on inflammation. So I may use some information that you already know, but I want to make sure you get all the information that you need for this, to understand this issue. So obesity is an excessive or abnormal accumulation of fat deposits linked with a mild chronic inflammation. Okay? We have not seen anything, as far as I know, about inflammation and obesity so far. So obesity, at some point, will produce inflammation, and that would lead to all the related comorbidities: type 2 diabetes, cardiac failure, cardiorespiratory problems. Well, you have all of them here. Well, and there are much more than that. So very briefly, the relation about obesity, adipose tissue, and inflammation with the adipokines. So we have our adipose tissue is considered right now an endocrine organ, so it produces a lot of adipokines with different functions. You can see here, for example, they are related with insulin, with blood pressure, with hemostasis, angiogenesis, inflammation, and many other things. Another thing is that when we are obese, our WAT mass, our white adipose tissue mass, increased, and that produces a dysregulation of the production of these adipokines. So you can see that from a normal adipose tissue, we get to a very huge adipose tissue infiltrated with macrophages, and with a dysregulation of this adipokine production. For example, leptin, TNF-alpha, IL-6, and aptoglobin are increased, which are mainly related with inflammation. They are pro-inflammatory. And adiponectin is anti-inflammatory and is decreased. Okay? Sorry. Also, these changes are thought to help our body to adapt to the new situation and increase the vascularity of the adipose tissue. And as you have seen, adipose tissue is infiltrated with macrophages, which are part of the cells related with our immune system, our protection from external virus or bacteria. So the hypothesis is hypoxia in an excessively expanded tissue leads to an inflammation, okay? That inflammation would help our body to adapt and increase the number of veins and arteries and the vascularization of the adipose tissue to reduce that poor oxygenation of the adipose tissue. So there are two things here important. One is we are thinking there is hypoxia in our white adipose tissue, and the other is that that hypoxia is producing or at least helping that inflammatory process. Okay, so to try to prove or to understand how this hypothesis came out, we need to go to these two sentences. Obese people, back in 2004, we knew that obese people do not have a higher amount of blood than normal people. So the blood flow was pretty similar in normal weight people than in obese people, okay? And also, in obese people, we get adipocytes, which are larger. And that means that they would be further from the vasculature. So they will get less oxygen. Okay? So you have here the adipose tissue. That rounded yellow cells are the adipocytes. And the red arrows are the veins and the arteries that provide, the arteries that provide the oxygen to our tissues. So if the person is eating a lot, these adipocytes will increase in number and in size. While, although you may think that the red arrows have gone smaller, they are exactly the same size as they were before I touched the activation. So you can see that now we have a bigger amount of cells and bigger cells, but we have the same amount of blood. So we have less oxygen, and also because of the size of the adipocytes, it is more difficult for the adipocytes to get that oxygen, okay? Oxygen is transported in our cells through an aqueous area, in a way, okay? And adipocytes, as you know, are lipidic, so the bigger they are, the more difficult they will get oxygen. Okay, so this was in 2004. It was a big risk. It was a hypothesis. It was not proved. But after some time, people started doing some experiments to see if that hypothesis was true. So first, in vitro in 2007, Wang et al. Showed that hypoxia in human adipocytes increased the pro-inflammatory and decrease the anti-inflammatory adipokines. So it could be related with inflammation. And in vivo in animals, in 2008 and also in 2007, several groups showed that OBOB mice and KKY mice, which are big fat mice, so we understand, and also high-fat diet mice suffer hypoxic conditions in their adipose tissue. Okay? And finally, in 2009, all the hypothesis was completely proved with human beings. Pasarica et al. Showed that as we increased our percentage of body fat, we decreased the quantity of oxygen that is in our adipose tissue. Okay? So you can see here, white fat tissue from lean subjects has more or less 48 millimeters of mercury of oxygen. In obese, we have around 15 millimeters. So what do you think? Anyone? Do you want to exercise again? No? So it's pretty obvious. We have hypoxia in our white adipose tissue. So now that we have that knowledge, obviously what we are trying to do always is to treat obesity in human beings. So how can we use that knowledge? Oh. Okay, so now we know that the hypothesis was true. So hypoxia, there are three different theories. Hypoxia leads to oxidative stress, to endoplasmic reticulum stress, and to hypoxia. And these causes, either one of them or the three of them, would lead to inflammation and that to the related comorbidities. Okay? Okay, so to show you that we are not the only ones interested in that and that the field has gone up quite a lot since the last years. If you check hypoxia in PubMed, you get around 100,000 articles about hypoxia alone. Since 2008, you get 14,000 articles. If you check for hypoxia and obesity, you only get 755. That's a small quantity. People still are looking a lot for cancer. Obesity is not something that everyone understands the problem, so not everyone studies. And hypoxia and obesity since 2008 gives us a 30%, okay, while the other one is around 15%. So a lot of, well, not a lot of people, but more people is looking into it now. Okay, I know some people would not have a molecular biology background, so this is the only slide which could be a bit more molecular, so I'm not going to get much into it. I'm just going to show you in hypoxia there is something, a protein, which is very important, which is HIF, the hypoxic inducing factor. Okay? And we have two parts of this hypoxic inducing factor, HIF-1 alpha and HIF-1 beta. HIF-1 beta is expressed constitutively. This means that it is expressed no matter what happens, okay? But HIF-1 alpha is expressed only in hypoxic conditions. Well, sorry, it's expressed all the time, but it is degraded in normoxic conditions, while in hypoxic conditions it's not degraded and it will join HIF-1 beta and produce all the effects in angiogenesis, erythropoiesis, apoptosis, and many things. Okay, so the group of Paul Traherne and Stuart Wood, which were the people who started with the hypothesis, have done a lot of experiments and have shown what you see here. Glucose uptake is increased in hypoxic conditions. Lactate is increased as well. The adipokines are dysregulated. There are also some effects on mitochondria. Okay, that's the article that Alfredo has given to all of you. It's about the angiopoietin-like 4 protein one, which is a protein related with angiogenesis. And we showed that in normoxic and hypoxic conditions, this gene was behaving differently with different amounts of fatty acids, palmitic acid, oleic acid, arachidonic acid, and eicosapentaenoic acid. Okay, this is very important because obese people usually tend to have double the quantity of fatty acids that normal people have in their blood. So that together with hypoxia would also lead to these problems. Okay, so as a summary, proteins related with angiogenesis and with inflammation are increased, with anti-inflammatory proteins are decreased. Well, MT3 metallothionein 3 is increased a lot, and just that sentence, hypoxia by itself upregulated 650 genes and downregulated 600 genes, okay? Well, I said glucose uptake, and fatty acids can amplify this effect of hypoxia. And preadipocytes are also affected. Okay? Any questions so far?
Is all the inflammation explained by the hypoxia? As you said, fatty acid increase.
Well, it's one of the explanations. In 2004, this group from Liverpool made this hypothesis about hypoxia. But also in 2004 and 2005, two other groups made the other theories, the one that I've shown about oxidative stress and endoplasmic reticulum stress. So till then, there is a lot of discussion in the scientific community about which one is the reason. My opinion is that the three of them are occurring and the three of them are complementary. Which one of them starts, I don't know. I don't know if I really care, to be honest with you. I mean, what I want to know is what is happening and if we can help and do something to solve it. I don't want to say who's the main character. I just want to try to find a way to solve obesity. Any more questions? No? So now I'm going to start with the studies that we are conducting. First of all, the title of this presentation is oxygen therapy. When we talk about oxygen therapy, we usually think about hyperoxia. It's giving oxygen to people that needs that oxygen, usually for respiratory problems, okay? But we have used hypoxia and hyperoxia. So I would like to use the term of oxygen therapy for both things. So here you have the hypothesis of the group. Pablo is the first author of this review, in which we present the hypothesis about how important could be hypoxia or a hypoxic or a hyperoxic treatment for obesity. So here you can see the two hypotheses. And now I'm going to start first with hyperoxia. And I'm going to go from in vitro to animals to humans and hypoxia. Okay, so I'm probably not going to present all of the results in chronological order, but I'm going to present them the way I think you would understand better. Okay? So now we are going to talk about hyperoxia. We are saying that there is hypoxia in the adipose tissue, okay, and that hypoxia is leading to inflammation. So, just to make it more difficult, if we give oxygen to an obese patient, what would you think it would happen, or what would you expect it would happen? You have no idea? Okay, well, what we were expecting is that if we have hypoxia, that hypoxia is leading to inflammation. If we give oxygen, we are reducing the problem, so hopefully we are decreasing the dysregulation of the adipokines and reducing the production of pro-inflammatory adipokines. Okay? So, in a sense, we are trying to reduce the inflammation. It would be difficult to reduce weight with that, but we hope to reduce the inflammation, and that would reduce all the related comorbidities. Okay? So maybe I didn't point this out very well in the previous slides. Inflammation, we consider inflammation the most important problem of obesity, because type 2 diabetes, cardiovascular problems, respiratory problems, oxidative stress, and all the related problems that come when we are obese are usually because of inflammation. Okay? So if we can solve or reduce that inflammation, we should be reducing all the related comorbidities. Okay, so you can see there, IL-1, IL-6, TNF-alpha are pro-inflammatory adipokines, and with this treatment we hope they will decrease, and adiponectin we hope it will increase. Okay, so basically inflammation reduction and amelioration of the obesity disease or pathogenic state. Okay, so now, because I knew by this time we would be already quite sleepy, I have a video, because for many people hyperoxia treatment or hypoxia treatment sounds like a bit science fiction, don't it? What do you think? Yeah? So I have a video here, and another one will come later to show you that it is something that is done in humans, and it is done in a medical environment as well. Well, hopefully it works. So while it is getting there, what we are going to see here, it's a hospital in which they have a hyperbaric chamber which gives oxygen to patients with different diseases, even diseases from the brain. It is something that could be used for osteomyelitis, which is something related with neurons around the brain. Well, obviously, as you have seen from...
this tiny dancer, Gianna Powell, is doing just fine now. But only weeks earlier, she was partially paralyzed by encephalitis, a viral infection that goes to the brain and can cause serious impairment, even death. Gianna's mother, Tammy Powell, was ready to do anything, even planning to go overseas for specialized oxygen treatment.
I had figured we were either going to go to the UK to get treatment, or I knew there was a private clinic down in North Carolina.
But Gianna and her mom finally found help here at the DMC's Detroit Receiving Hospital with its new oxygen-giving hyperbaric chamber. Gianna says she wasn't afraid of the process.
But there wasn't any pain?
No.
It didn't hurt to go in there?
Mm-mm.
And it really wasn't... Is it scary being in that tube?
No. Maybe the first time when you look at it, you'll be like, oh my, I'm going in that?
It's a little intimidating.
Yeah.
Dr. Bob Wilson is chief of the Hyperbaric Oxygen Therapy Program and chief of staff at the DMC's Detroit Receiving Hospital.
We had a young girl who came in with encephalitis, and the encephalitis hit her so hard that she could hardly move anything. And within a few treatments of starting this thing, she began to move, she began to walk. And after she finished her treatment, she was able to tap dance, which is almost unheard of in people who have been paralyzed from encephalitis.
That's incredible.
Oh, it's a miracle. It is really a fantastic thing.
There's some patients in here now.
Yes.
The hyperbaric chamber is a non-invasive, painless, high-oxygen pressure treatment used for a number of conditions and illnesses, including diabetic ulcers and other non-healing wounds, necrosis of soft tissue and bone due to radiation treatments, gangrene, and more. Inside the comfortable multi-person chamber, pure oxygen is administered at an air pressure 2 to 3 times higher than the external atmosphere. The patient's white blood cells increase significantly, increasing their opportunity to heal.
Well, I just wanted to show you the hyperbaric chamber so you see it's not science fiction. People use it and people get a cure of their diseases with this. Obviously, as you have probably gathered from the big smile of the guy at the beginning, they want to sell us the treatment. So they are only saying good things about it. But I just wanted to show you how it's a hyperbaric chamber and that it is something that it's in medical environments, in hospitals. I've shown you this list of diseases before, where it says HBOT is hyperbaric oxygen therapy. So all those diseases could be cured by this hyperbaric chamber. And at the right is normobaric oxygen therapy, which is something that we could have in any room of a hospital. I don't know if you've been in a hospital and you've seen that usually next to the beds you have a sticker saying O2 or I don't know if it says CO2, I don't know. Well, O2 for sure. So that's for the normobaric oxygen therapy. Okay, so starting with our studies. We have done studies in cells, in 3T3L1 cells, which are adipocytes from mice. We have used this here, which is what we call the hypoxic chamber. We can do hyperoxic conditions there and hypoxic conditions as well. Okay, so first we tried 21% of oxygen and 95% of oxygen for 48 hours. That's massive, that's huge. If we give to a human being for this kind of normobaric oxygen therapy, we usually give 100% oxygen, but it's like 2 minutes rest, 2 minutes, and very short periods. Here we are talking about 48 hours. Cells allow us to do that. So I just want to show you here, I don't want you to pay attention on the biochemical parameters or the genes that we are going to see later. I just want to show you that hyperoxia is producing an effect, okay? We are getting a higher amount of glycerol in the media after we use this hyperoxic treatment. So it's somehow breaking the adipocytes and liberating part of the lipids that are inside of the adipocytes. We obtain also a regulation of some genes. So hypoxia is regulating genes, but hyperoxia is regulating as well. Okay? Well, obviously we checked, before we start with our experiments, we checked the literature. There are some other groups working on the same topic. So now with animals, we want, with cells, I could have shown you a big cell and a smaller cell, but it's not as impressive as you see this big mice and this normal one. So we want to start from here and get to here with the treatment. So you can see here the way we work. We have the mice in those boxes in which we generate either hypoxic conditions or hyperoxic conditions. This here gives us the content of oxygen which is inside of the box. And this is a valve that allows us to control that content of oxygen. If we want a small amount of oxygen, so we have 21% in the room. If we want to take some of that oxygen, the easiest way is to pass nitrogen through that boxes, okay? So we have control animals, normal size, high-fat diet, high-fat sugar diet animals which would get obese at some point. Okay, and the same here. 2 of these groups with 21% of oxygen and 40% of oxygen for the others for 8 hours a day during 18 days. We have decreased the quantity, okay, because now we are with animals. So unfortunately, we could not see any difference in the size of the animal, in the weight of the animal. So we were unsuccessful in that. Glucose, cholesterol, HDL, triglycerides, lactate didn't show any difference as well. So we went for the other hypothesis. But anyone has an explanation why that didn't work or want to give us any advice? Well, we have an idea, obviously, but I want you to try. Nothing? Okay. Our explanation is adipose tissue. That is one of the thoughts I told you to keep before. Adipose tissue is very bad vascularized. It's one of the tissues less active and less irrigated in our body. Okay? So if we give oxygen to the whole body, that would be distributed around the body, but to the adipose tissue we will get a very small increase. Okay? So that's why we thought that would why this didn't work. So we went for the other hypothesis. What if we treat the animals with hypoxia? Because mammalians, mice and humans, adapt very well to the changes of oxygen. As you have seen with the flies, they increase or decrease the size because of that oxygen. We use our blood and our hemoglobin to adapt to that situations. So if we train a human body or an animal body to have less oxygen, the adipose tissue at some point will not be a problem. I mean, the oxygenation of the adipose tissue would become normal or would get oxygen easier because we are adapting our body to less oxygen. Okay? But we have this hypothesis also because there are climbers who suffer hypoxia, and there are some symptoms because of that. Like, for example, appetite suppression, they lose weight, their adipose tissue is reduced, and HIF1 is activated. So you can see here, altitude sickness, low partial pressure at high altitude, and they may have nausea, they have lack of appetite, insomnia, well, many problems, but mainly we are interested in this one, lack of appetite. So another video.
Now let's take a look at the new secret weapon used by a lot of the leading athletes around the world.
A number of professional and amateur sporting clubs around the world, including China, Australia, New Zealand, have actually purchased go-to-altitude training devices for the benefit of their athletes. Both their health and well-being as well as their sporting performances have all benefited from this device. The way the go-to-altitude hypoxicator system works is it draws in normal atmospheric air, which is around about 20.9% oxygen. The air then hits a semi-permeable membrane, and some of the oxygen diffuses across, others doesn't. What then happens is the machine draws out nitrogen-enriched atmospheric air to provide to the athlete to breathe, which is lower in oxygen concentration, and hence the athlete gets less oxygen supplied to them.
So what benefits does this have for the athlete?
The benefits of IHT, or intermittent hypoxic training, for the athlete are quite wide and diverse. We actually see an increase in the concentration of red blood cells, which means the athlete has the ability to transport more oxygen around the system, which allows the athlete to stay aerobic in their exercise for a longer period of time. We also have a bolstering of the immune system function, so the athlete doesn't get as sick as often, and it also has a little bit of an improvement in the athlete's ability to recover between intermittent exercise as well. At the moment, Brendan's breathing air, which is the equivalent of being at the base camp of Mount Everest, which is about 6,000 metres. The air at that level only has about 11% oxygen compared to normal atmospheric air, which is approximately 20.9%. Quite simply, the benefits of that are that it will stimulate the body to produce more red blood cells, which makes it easier for the body to transport oxygen around the body systems.
So for the ordinary person?
Research out of the Soviet Union has also shown that IHT has had beneficial effects for people suffering from chronic fatigue syndrome, female infertility, and general health and well-being.
So let's talk basically. How would this help?
Okay, so you've seen again that. So you've seen again that hypoxic conditions are not science fiction as well. The only thing that another important thing that you have seen there is that they were talking about athletes, okay? So please lift up your hands, people who likes and knows about football. Okay? Without Pablo and Raul, which know the answer for this, but anyone knows an athlete who uses these hypoxic chambers? Okay, very well. Yeah, so many athletes, not that many in Spain, but many maybe in the US and in Canada and in Australia, are using these hypoxic chambers to increase their oxygen transport efficiency, so they recover better from their sports and they get better marks. But we want to use this with obese people or with obese animals. Some other groups have used these hypoxic situations with obese people. Now we are going to talk about the study in animals. So we gave to these animals 8% of oxygen. Okay, do you remember from the previous slides at what height are we putting them? Something in between the Everest and the highest city in the world. Okay? But as I said, animals adapt quite quickly to these situations. But here you can see the intake, okay, food intake. The gray areas are when we gave the hypoxic treatment. So you can see that when they were in hypoxic conditions, they decreased their food intake. And after a few days, they decreased their weight. Okay? This was a pilot study, so we needed to get more information. The other thing here, which would become important afterwards, is that they lose weight, but they mainly lose muscle. Okay? We didn't know why, but it is important because what we want is to reduce fat percentage, fat mass. Another study with a bigger amount of rats, we used again 8% of oxygen. We changed a bit the days of the week where we were given the hypoxic treatment. And unfortunately this time we got a smaller decreases in intake and also a small decrease on weight. So that was not significant. but it was promising. And now the last part of the studies. Always, if we are working in science, if we are working in research, what we want is to treat the human beings. So what we want, our end-up goal is to be able to help human beings, and in this case, to reduce obesity. While I was looking for these photos, I saw also the Catherine Zeta-Jones that we saw at the beginning, but I thought, well, I'll use another one. So this is the hypoxic chamber that you have seen before. One important, very important thing is that we are talking about humans. There is a lot of variability between human beings. So when we were using animals, we had the same amount of oxygen in the whole box for all of them. This time, what we are going to control is the same saturation of oxygen in their bloods. Okay, because for example, normal people has a saturation of 97, 98 in normal conditions. Obese people directly, without doing any exercise, has around 92, 93, so they are already different. Okay? And also, as I told you before, when you did the exercise, some of you were a bit more tired because of the exercise, and some of you were like peanuts. I did nothing. Okay? So in the literature, it has been proved that hypoxia improves respiratory function. I mean, not only the guys in the video which want to sell you the hypoxic chamber are saying this. Very important groups in the scientific community are saying that it improves respiratory function, enhances insulin sensitivity, protects cardiovascular system, increases body weight loss, and activates angiogenesis. So, talking about human, we have not started yet, but we are going to do an experiment in next September in Vitoria, in the Chagoricho Hospital, in which we are going to treat obese people with hypoxia and also with physical activity. If you remember, we saw in animals that we reduce the weight, but we reduce muscle. So we thought, if we increase the physical activity together with hypoxia, we might reduce the problem of reducing muscle, and we might reduce mainly adipose tissue. So this is mainly advertising. If you know anyone in Victoria area, which is what I would call a healthy obese, so not big problems in cardiovascular system, not big problems in respiratory system, please tell them we are going to start something. So to sum up, oxygen therapy and obesity. Hyperoxia could be very useful to understand how certain genes are oxygen regulated. I mean, we didn't find what we were looking for with hyperoxia, but we know hyperoxia is regulating some genes, and that would give us some more knowledge about all this oxygen regulation. Hypoxia has been confirmed as a good therapy to improve cardiorespiratory status, as you have seen in the two previous slides. Hypoxia seems the right option to help people to lose weight, but we need to find how it works in the long term and in humans. I mean, obviously it's a risky thing to do. Hypoxia, it's something that athletes, which are like superhumans in a way, can use it. Now we are going to obese people, which, well, I'm not going to say anything, but they are just not as healthy as athletes. So we have to be very careful. And also the variability is very important in this sense. And obviously we still need to answer some questions, as we will always do. So thank you for your attention. I have also the same photo as Alfredo, but it's smaller. And we, as some other speakers have shown in an aerial view where they work, so I would like to do the same. So we work here, and thank you for your attention. Any questions? Did you understand it? Oh, sorry, a question I was. Yes, you can, and I'll try to answer. As you have seen, you may not remember from one of the slides of Professor Trehorn, glucose uptake, it's increased. That's why, because with less oxygen, we increase the anaerobic metabolism. So we increase the need of the use of glucose to obtain energy. And it's, again, like the hypoxic situation. Hypoxia is not good, but we are training our body for a stressful situation. So that hypoxia would help the body to adapt in biochemically as well, to get more efficiently the energy. More questions?
Would it be practical to use if it did work, and the expense side is apparently quite expensive?
Which one?
The tents.
They are very expensive indeed, but those tents are mainly for scientific purposes. Yeah. So just a month ago I was checking for other possibilities, and there are like mechanisms that you can wear yourself at home, and it's not like a tent, it's just something this big, and it was about 1,000. But please don't get into internet and buy one for you. I've just said the good things about it, so don't get ill because of me. Well, that's one of the things we need to find out yet, because as I said, the variability between human beings is very big, and so our next goal is to kind of find a protocol of time of exposure, quantity of oxygen, if the physical activity is needed as well, how many physical activity is needed during hypoxia or outside of hypoxia. With this study, we want to solve many questions, but we still have them. So. But for example, one of the studies that I showed in that table of literature, they took obese people to 3,000 meters in the Swiss Alps for, I think it was 2 weeks without any exercise. And they lose some weight, and 40 days after they were in this height, so they were moved back again to more or less sea level, and 40 days after that, they checked for their blood pressure, and their blood pressure was maybe not normal, but it was decreased. So it could be just a little, and the good thing about hypoxia against hyperoxia is that the effects of hyperoxia are for the short term, while the hypoxic situation, what you are doing, you are not treating the body, you are adapting the body, you are training the body. So that gives us a longer term treatment.
More comments?
Pablo, Raúl, any questions? No?
Then I will appreciate your help in these days, and if you agree, we can just have immediately a summary of all the presentation that we have had during the last 3 days, and after that, if you have some question, we will try to respond, and we will make the final closing of the course, okay? We are going to sit down and we are going to make a small summary instead to go to give the passport, or the note, and we will finish with this. Okay. The idea when we designed this course, this summer school, was to present a number of views covering different aspects of personalized nutrition. Probably all of you have noticed that the speeches has been different, but always with a focus in knowing the mechanisms, in identifying processes, and in a final view to try to know how to apply it for personalized nutrition. In this case, Pedro will help me, but you remember we have some lecture devoted to lipid metabolism. Some of them were devoted with differences between different countries and ethnicities. We have devoted also how to drive or to deal with obesity management, and we have also developed some, I would say, attractive hypotheses of how to treat obesity or how to use functional foods. I will appreciate that Pedro will make a small summary of the views we have been seeing during the last 2 days, and after that we will make the closing. Okay?
Okay. So I'm going to give a very small summary of some of the talks. Obviously it would be very biased because it's what I write down, so it was things that I was interested in, but hopefully it is most of the important messages. So for the first talk, for Guy Plasky, ethnic differences in body composition and substrate utilization, he told us that Asians have a lower energy expenditure than Caucasians. He told us that they have a bigger amount of fat mass, the Asians. So when you adjust this energy expenditure by fat-free mass content, the difference disappeared. They found that Caucasians have more fat-free mass than Asians and less fat mass. And they found no differences in substrate oxidation and in energy and substrate balance. So they could not find really what was the explanation for that difference. For the second talk, Andrew Salter talked us about, can we turn bad foods good? Apparently ruminants turn polyunsaturated fats, which we could call them good fats, into saturated fats, which are the bad fats. Some supplementation, like with rapeseed oil, could eliminate the probability or the risk of having atherosclerosis in the ApoE mice that they had. He proposed that you can select cows that produce or express a bigger amount of the SCD, the esteroyl desaturase enzyme that helps produce oleic acid. He also proposed about the given protected lipids to these ruminants. He told us that it was very expensive, but at some point that could happen. And he talked us also about trans-saturated fatty acids like trans 9 and trans 11. And what I understood from that is that if you industrially prepare these trans or these hydrogenated fats, they are very bad for our body. But if you have these trans fatty acids in an animal like the ruminants, they could be even good. Okay. I would just summarize the third talk, fetal programming of lipid and lipoprotein metabolism, what, why, and how, with his last slide. Genetic prenatal influences and postnatal influences will develop the human being in one way or the other. So in the talk of UCP Yamaki about fatty liver causes and consequences, I'm sorry I could not take any notes. For the next one, he said that cardiovascular risk, it's increased by systolic blood, smoking and cholesterol, and he presented us how they were involved. I don't know, well, if you want to add up something before I go to all of them, just feel free, okay? For the Mediterranean diet in North Africa, Rekia told us that they are shifting the diet from Mediterranean diet to Western diet, so obesity is increasing a lot in these countries, and not only obesity but also cardiovascular problems are increasing. Then he taught us about the difficulties that they have in these countries to convince the people how important it is to have a good diet and not to be obese. But you may remember my informal way of saying that male in these countries prefer women with a few extra pounds or a few extra kilos. So that's a big problem because they have to change their culture before they can convince them to lose weight. Lisa Ryan told us a lot of important information about functional foods. It's probably one of the biggest markets in nutrition right now. We have functional foods from natural ingredients, or we can prepare industrially functional foods. She told us about the difference between Japan and other countries. In Japan, she told us anyone would take anything that says healthy or something like that. In here, we need to see a nice color, even a nice smell, nice taste, and then if it's better for our health and it's not too expensive, we will buy it. But probably we will get closer to what Japan is thinking right now. She told us about the colors in these functional foods. You probably have heard about this already. If you prepare a salad, do it with as many colors as you can, because you will get the bigger quantity of antioxidants, vitamins, minerals. And well, I'm not gonna get into a specific antioxidants or functional ingredients, because she told us many of them, but just saffron, it was anti-cancer and anti-tumor properties. I don't know about you, but I was really surprised about how many properties those natural ingredients had, and we have them in a place in our kitchen where we just think it's part of the aesthetic of the kitchen. But they are, as she showed us, they are very important, and we need to use them. In the Mediterranean diet, indeed, they were very important. So probably in the Anglo-Saxon diet, they were very important as well. You can tell us. And
Okay, then I would like just to make some emphasis about the roundtable we had yesterday. as you will remember, and probably the people that don't speak Spanish was not able to assist or attend, but the roundtable was focused in 3 different levels. In one level, it was being devoted to food with slimming properties and reglementary and legal aspect. The second one was devoted to different diets that can be applied for body weight lowering. And in the third presentation by Dr. Navas, the main aim is the implementation of dietary regimens to weight loss. Of course, this morning I have been talking about the potential role of moderately high protein diet, in which, of course, I am talking about 30% of protein. Some of you asked me after the presentation how much amount of protein was involved. It's about 150 grams. And also, I would like to thank you, Peter, the last presentation about a novel approach to treat obesity by using the situation of hypoxia or hyperoxia in some situations can be used as a potential approach to treat obesity. And also, the last presentation by Professor Palet of the University of Bordeaux was devoted about the role of vitamin A. The final message that she brought to us is that maybe vitamin A could be a safe product to improve cognitive function in the elderly. Of course, she was prudent and she said that many studies are needed, but at least there is a possibility. Just to make my final concluding remark is that I would like that all of you focus all this presentation about what is going to be known as tailor-made diet, customized diet, personalized diet. In the future, I think the paradigm of public health nutrition will be maintained, will be applied, but in many ways, genetics, the genetic makeup, the family inheritance are aspects that we need to consider in the future. What about the explanation? Because some people reduce the body weight easily with an energy restriction of 500 kilocalories, and other people, other subjects, other obese are not able. Why? Maybe the explanation is in the energy efficiency, maybe the explanation is in nutrigenomics, and the explanation is in epigenetics, maybe in the future. Okay, this is my last word. I want to thank you again, all the professors, and of course, the attendants, and these are my farewell words. Thank you very much for coming, and see you next year in a summer school we are preparing already from now. Thank you.